Welcome to EduSoft Virtual Labs. The aim of the experiment is to determine the viscosity of a viscous liquid. The apparatus used will be a long tube filled with glycerin, a number of small steel balls of different sizes, and a stopwatch. Viscosity, or internal friction, is associated with the occurrence of friction forces between two layers of a gas or a liquid, which flow parallel to each other at different speeds. The cause of internal friction of viscosity is the transport of momentum by the molecules from one layer to another. According to Stokes' law, a small sphere of radius A falling through a viscous medium of viscosity coefficient eta acquires a terminal velocity v and calls into play a viscous force Ft. In the steady state, the forces acting on the sphere are the weight of metal sphere downward, the upthrust force and the friction force. At equilibrium we get the following relations, where ρ and sigma are the densities of the sphere and the medium respectively. The relation between v and a squared is a straight line from which eta can be calculated. Sometimes end effect and wall effect must be taken into consideration to obtain more reliable results of terminal velocity. Now let's start the experiment. Two marks of known distance apart are labeled on the glass tube. Make sure the top mark is sufficiently well down the tube to ensure that the sphere acquires its terminal velocity before passing by it. Take a sphere of known diameter, and leave it above the liquid surface to descent in the tube. Calculate the time of descent of the sphere between the two marks. Repeat the last steps with different sphere diameters, and calculate the descent time for each sphere. Plot a graph between R average squared against V average, and draw the best line through the origin, and from the graph find the slope, and then calculate the coefficient of viscosity.